focused around DevOps, or what is commonly known as the interaction between developers and operations. So what we've seen over the last 10 years is we've seen a lot of adoption of agile development practices, which focuses on small incremental development life cycles where you're continuously delivering some unit of work or some product to the end user. What has happened, though, is that the areas outside of IT, which are responsible for build and deployment, have not caught up. And so what you're seeing this funnel effect, where there's two distinct ways of delivering or developing software, all located within the IT development process. So what I'd like to coin that is where developers like to always want change, and operations is always striving for stability. So you have these two conflicting goals, which then creates a wall of confusion. And what we're going to do is we're going to talk about this wall of confusion and what Microsoft is doing in that area. A little bit about me. I am again the ALM practice director for Neudesic. Prior to Neudesic, I spent 13 years at Microsoft as a principal technology developer specialist and a Microsoft consultant. I'm a Microsoft Virtual Technology Specialist and a Visual Studio ALM Ranger. I've been developing software and have played various different roles in the software development lifecycle over the last 20 years. So with that, let's get started. Let's talk about this wall of confusion. So you are seeing here kind of a short description of what typically happens in a traditional software development environment. You're seeing development just does their thing, they follow their processes, and then just tosses things over the wall to operations, and they expect that it magically appears. And so the biggest area that we're seeing is that the build and deployment into production is very important, because that is the only way an end user is going to be able to see the results of your development process. So why adopt DevOps? Like I said earlier, the use of Agile and other development processes and methodologies has really focused on how do we increase that agility through the other areas of the software development lifecycle. And this includes what happens once you've completed the code and you've tested it, what happens when that gets moved over to the deployment stage and the production stage. There's an increased rate of production releases from application business unit stakeholders because of this agile development processes and the agility that businesses are now expecting from IT. You're seeing an increased rate of demand, and so you have to really solve this funnel effect. There's also wide availability of virtualized and cloud infrastructure from internal and external providers. So that wide availability of virtualized and cloud infrastructure environments makes the ability to bring agility into the operation side more realistic. You no longer have to be limited by on-premise solutions or the lack of scalability by on-premise solutions. You now can leverage virtualized and cloud infrastructure environments to really achieve that agility and marry the ability to bring production applications to life a lot quicker, and you can time your releases with what's happening on the development side. Again, there's an increased usage of data center automation and configuration management tools, which means these things are making the adoption of quick deployments very easier. And so what you're seeing here is you're seeing this whole concept of now, not only have I adopted agile development processes, but now I'm having this continuous delivery of product throughout that software development cycle. So I'm seeing development happening quickly, and if I can bring agility to operations, I can now deliver software on a continuous basis. When that doesn't happen, and so what you're seeing here is a diagram of what currently is existing now. So you see along the lower left-hand side of your screen, there's the traditional agile development where you're delivering in increments in very short iterations. But what's happening is once you go into your different release stages, you're still following the traditional waterfall approach where you have those time box releases waiting for something else to happen before you can go on to the next stage. And so there goes your agility, right? the time improvement or the productivity improvement that you gain through agile development is now being lost through the build and deployment process. So let's look at what Microsoft is doing along those lines with the Visual Studio 2012 platform. So what you're seeing here is you're seeing the continuous delivery lifecycle as we see it now. Traditionally, developers are focused in the lower left-hand quadrant under where it says develop, where you work in that iterative fashion and you implement units of work in small increments. But there's a lot more to that than just that development quadrant. You now have to look at what's happening throughout the entire software development lifecycle. And it begins with define, right? You have to have some sort of idea or some concept that needs to be broken down into really well understood requirements so that developers can actually understand what they need to build. Because it does you no good if you're building software that's robust, very well architected, and well tested, but it doesn't meet the requirements. Actually, producing an application does not meet the requirements well will affect you more than bugs in the software development lifecycle. So you start with well understood requirements. You now pass that over to development. You make sure that you're building quality into your iterative cycle and you're implementing those requirements into actual unit of works inside your product. Lastly, this is the area we're going to be talking about now, is you move that over to operations. And operations is very key here because they're actually taking your working software and putting it to use. And so what you need through having working software in production is to have your end users be able to provide you actionable feedback. Not only actionable feedback on bugs or incidents that are happening in your application, but also scalability. How is your application going to scale? Is it going to scale well out there? What are the various things that I need to do in order to re-architect my application so I can scale? You also need to get actionable feedback from your end users on ways that you can improve. All that information needs to come back into the continuous delivery cycle here in the form of requirements, new requirements. So as you go through the next iteration of your software development process, you're learning on the things on the feedback that was captured during your first release. So there has to be a tight integration there with operations. So let's look at what happens when operational requirements are not met. So when operational requirements are not met, you have longer bug cycle times, customer dissatisfaction, and the mean time to repair increases, right? So there's costly remediation of the things that you need to do in order to fix the production errors if they're not caught quickly. So how do you solve that? How do you mitigate operational requirements not being met once you have deployed your software application into production? You mitigate that now through various agile ways of monitoring that production application. And so on the Microsoft platform, you do that through the form of System Center. So System Center 2012 now provides management pack templates that allow real-time monitoring of production applications. And it has all the predefined information that you need in order to monitor that application on the Microsoft platform, and it makes it really easy. So how do we do that? Let me switch over here, and what I'm going to show you now is Microsoft System Center 2012. So I have running here is a virtual environment with System Center, and this is primarily known as System Center's Operations Manager. And Operations Manager is the main interface by which you would set up the things that you need to do to monitor your application. If we look over to the left-hand side, you notice we have 4 different tabs or views that we can use and leverage inside Operations Manager: monitoring, authoring, administration, and your workspace. I'm going to focus on the top 2, monitoring and authoring. So how do you begin to monitor an application that you've built? The first thing that you need to do is actually author and create a management pack for your application. Now, management pack has all the information that System Center needs in order to provide that monitoring for you, that real-time monitoring for you. And you leverage System Center Management Pack templates, which allow you to provide that information to your application. And there's various different templates for various different types of applications. So if you were developing a typical .NET application, you can see here, I can leverage the .NET Application Performance Monitoring Pack template. So if I look under there, I can see here that I already have created a management pack for my FiberCam Fiber sample website using the .NET Application Performance Monitoring template. So if I click on the details for this management pack here, it's going to open up all the different settings that are already provided to me out of the box through that management pack template. All I really have to do here is tell the template which application I want to monitor. So in this case, I want to monitor my typical web application, and in this case, it's going to be my FiberCam Fiber demo application. It's just a customer monitoring site, intranet site. I can set up my server-side defaults. I can turn on performance events, turn on exception events, and I can set up a performance event threshold. Now, this is 5,000 milliseconds. That may not be realistic in a real-world environment. For the sake of this demo, I really want to get some fast feedback when an error happens in my application during production, so I'm setting that for a very quick response time. I can also look in advanced settings. In advanced settings, I can actually even configure a sensitivity threshold that's even smaller than that. So in this case, it's going to be just 100 milliseconds. I can configure exception event monitoring. In this case, I'm going to capture all my critical exceptions, all my security alerts, all my connectivity alerts. I can then add some additional performance monitors if I wanted to. You already get some with the management pack template right out of the box. So in this case, since I leverage the .NET Application Performance Monitoring template, I already have some performance counters there set up for me. So I can cancel that. I can also do client-side monitoring, where I'm going to make use of JavaScript on the client side to bring back application information from the client that I can monitor. So if I go in here, I can say I'm going to go ahead and monitor my FiberCam Fiber website. I can set up some client-side defaults, and notice I can even configure client IP addresses where I can filter by client IP. So maybe I want to take a performance monitoring sample from just a subset of my clients. I can go ahead and pick some specific IP addresses in here that I want to focus on. And then lastly, I have the summary tab, which tells me all the settings that I've set inside my management pack. So after I've done that, I already have set up my application to be monitored through System Center. So the next thing I do is I can go down to monitoring. So I'm going to go up to the monitoring tab, and I'm going to show you how that works. So in monitoring, I can go and look at my application monitoring. Notice I have different folders in here. I'm going to focus on this application monitoring. I can go down and see the application I just set up for monitoring, which is my FiberCam Fiber website, and it tells me the state. It's healthy, it's running fine. I can have different views that I can look as I'm observing the monitoring state of that application, and one of those is the performance view. So I'm going to open up my performance view, and what this is going to do, it's going to bring up all the different counters that I set up previously in my management pack, and I can go ahead and look at how my application is behaving in real time. I can set like a time range, so I can either select specific start and end times for which I want to monitor, or this performance view, or I can select a time range. I can say the last 7 days, the last 2 days, etc. Those are things that I can do. And I have many different other views. I have an event view. I have a diagram view, which shows me the components that my application is based on. Those are the different things I can do as I'm monitoring my application. So let's go back to our presentation here. And so what we've seen is we've seen how you can monitor an application using System Center. What I'm going to do now is I'm going to show you the other things that can happen when you need to bridge that gap between development and operations. So I now know that I can gather actionable feedback from my operations folks through the use of System Center and the ability to both author a management pack for an application and then monitor it. One of the other things that can happen is if I have a different set of tools that I'm using, so now what you're seeing here is developers are using Visual Studio, operation folks on the Microsoft platform may be using System Center or some other operational management tool. You then have isolated tools and workflow. So you still have a disparate set of tools and you still lack the ability to have these two camps communicate effectively with each other and share information. Because as a developer, I need some way of gathering that feedback, of getting that feedback that the operations folks are getting during production. I need some way of getting that. I also need some way of getting all the diagnostic information that they may be seeing. So what happens when you have isolated tools and workflows? You have poor communication. Again, you increase the production bug fix cycle times, and you have customer dissatisfaction. So how does Microsoft solve that? Microsoft is solving that through integrated incident management tools. So now, through the integration of System Center with Team Foundation Server, you're now seeing a common view of incidents for both operations and development. Not only that, you have the ability to reuse the same artifacts. So you have this concept of shared artifacts, which allows you to reuse development artifacts such as tests inside System Center so you can reduce the rework and discover production issues a lot quicker. So let's look at how that integration works. So I'm going to go back to my demonstration here, and I'm going to go back to the authoring tab, and what you're going to see here now with System Center 2012 is you have a new management pack template of type TFS work item synchronization. And that management pack template allows you to provide integration between System Center and Team Foundation Server. In this case, I've already set one up between Team Foundation Server and my FiberCam Fiber project. So let's open that up and see how that works. So the first thing that you need to do as you're setting up your management pack for TFS is you need to provide a team project collection URL. So you want to provide the URL for your team project collection. The next thing you do is you provide an account that's going to be used to access that team project collection, and you want to make sure it has all the proper administrative rights. If you go to project settings, then the next thing you need to do is define which project in that project collection is going to be synchronized, because you can set up many different types of synchronization to the same TFS project collection, all for different projects. In this case, I'm going to set up a synchronization with the TFS project that corresponds to my FiberCam Fiber website. And all I really have to do here is specify the team project, and if you notice, I can go down and scroll here. I can have a lot. If I had more projects on that project collection, I would see them here, and I specify an area as well. And that's pretty much all I have to do. And at that point, I'm already synchronizing with Team Foundation Server. So how does that synchronization work? And here's where I'm going to show you how you can reuse artifacts. So if I go back to monitoring, one of the things that I can do here as I'm monitoring my .NET application is I have this concept of active alerts. And I'm going to show you how that works to alert me to any production incident that's happening as my application is running in production. So I'm going to bring up my sample application. You can see here it's the FiberCam Fiber intranet. It's just a standard support application for logging customer incidents, and keeping track of both incidents from customers and employees, and providing reports on that. So I'm going to log into this application. And as I'm waiting for it to log on, what I'm going to do is I'm going to fire off an exception using this application. And this application is already being monitored by System Center, so I should be able to see that exception in System Center in the form of an application alert. So at this point, I'm waiting for my application to log in. And while that's logging in, I'm going to go back to my operations console here, and I can show you there's a active alerts folder. If I click on that, it's going to show me some active alerts. This is an alert that I created earlier. And let's go back to our application. It looks like there may be some issues happening with my application. I'm just going to go ahead and refresh it. So I'm going to go ahead and refresh, and hopefully I can get back in here. And I can show you a real-time alert. All right, so I'm here. So I've logged in. I'm inside my application. I'm going to go ahead and produce the reports. And, I have an error here. So I actually created a real-time exception in my application. There's an error here. Obviously, something's preventing me from being able to view reports in my application. So at this point, I can close down my application. I can bring up my System Center Operations console. And let me see if I can refresh here. I should be able to see an alert that just happened right now, and I do. So I have an alert that happened, and this is the alert that was generated. So if I open this up, I can see I have some very good information that describes the exception that happened in my application during real-time processing. If you look inside the alert description, there's a hyperlink there that I can click on, and it will bring up some very rich diagnostic information for me to allow my developers to really troubleshoot the root cause for this production incident. But the issue that is happening is currently I'm viewing this as someone from the operations team. This doesn't really mean much to me because I'm not a developer. How do I get this information to the folks on my team that can really benefit from it, mainly my developers? That is the challenge that I see currently in the day-to-day use of different applications for operations and different applications for developers. So as this is coming up, I can see here some very rich diagnostic information. And I may be having some refresh issues here. But here you go. You can see here I have an entire call stack. I can see all the different things that happened, all the HTTP events that were executed. So this is some really nice information for me. So now with the integration with Team Foundation, Server, and System Center, it makes it very easy to reuse these artifacts. As well as I have some other tabs here that I can go through that capture information on my particular incident. One of the ones that you can see down at the bottom now is the alert status. So obviously, this is a brand new alert, so it has a status of new. But now, since I've integrated with Team Foundation Server, all these alerts are now actual Team Foundation Server work items. So what I'm going to do now is I'm going to pass this work item to my developers, and I do that through an out-of-the-box state called assign to engineering. Now again, this is just a standard Team Foundation Server work item, so if you don't like these different states, you can customize the work item and change these states. This is what you get out of the box. So I've assigned this work item to engineering, and so it's off my queue. I saw the alert, I've assigned it to engineering. Now I'm going to go in there as a developer and look at all the different production incidents that have been assigned to me. So now I'm in as the developer. I'm going to run a new query. Again, I'm just doing this for the sake of this demo. You can already have a predefined query that goes out and looks at all the different work items of type operational issue. That is a new work item type inside Team Foundation Server that I'm interested in. So I'm going to go ahead and run that query. And I can see here I have a brand new incident that I need to look at, and I'm going to open it. And this incident says, FiberCam Fiber Web on DevOps All, which is my server, had an application failure occur, an exception of type. And it actually has the same link to that rich diagnostic information that my operations person was seeing. It's now here in the form of my work item. So what I'm going to do here is I'm going to go ahead and change the state and say, look, I've accepted this. And the reason I've accepted it is incident is acknowledged. And so I'm going to go ahead and save that work item. So by doing this, I'm actually taking responsibility for that work item. I'm passing the chain of that issue from operations to development, and I'm letting my operations folks know that I am taking care of it. And so I can close that now, and it's been accepted. So now if I go back to my System Center Operations console, and I do a refresh of my alerts, and this may take a little bit of time, but if I open this up, I should see that the status changed to acknowledged. So now what this is telling me as someone from operations is that my incident was acknowledged and the developers are working on it. So now you can see how you have that tight integration between System Center and TFS that not only allows you to reuse information, reuse artifacts, reuse the same type of diagnostic metadata that you're currently used to using on either development or operations, but now you also have broken down that communication barrier. Since we're all leveraging Team Foundation Server work items, we have a workflow in place to share information and communicate statuses back to each other. So now let's look at another area where we can make use of these reusable or translatable artifacts. Production incidents are hard to debug and resolve. If production errors are hard to debug and resolve, it really poses challenges to the development team. It makes it very difficult to identify the root cause. You can hardly debug code, and it makes it hard to resolve defects. And this is common. A lot of organizations cannot afford to have the same infrastructure that you have in production in place in either a development, staging, or pre-production environment. It just realistically you can't. It's too costly. There's a lot of intangibles that need to be taken into account. If you have a lot of commercial off-the-shelf applications that you're leveraging, it even compounds the problem. So how do we solve that? Microsoft solves that, and this was introduced in 2010 in the development area through the form of actionable diagnostics. So IntelliTrace was introduced in Visual Studio 2010 to allow you to debug during the testing process in a pre-production environment. With 2012 now, you have IntelliTrace in production. So now you can apply that same principle of speed debugging and code fix in your production environment. You also now can leverage the same log files that are used in System Center, which are in the form of AVI-code logs, which have all that incident information that was captured during the execution of the application in production. You can now convert those to IntelliTrace logs so developers can use it as well. So you have that sharing of translatable artifacts. So IntelliTrace, for those of you who aren't familiar with it, basically it's a log file which captures all the code execution information as that application is running either in test and now with Visual Studio 2012 in production. So how does that work? Let me show you. Let's go back to our demo server. So in my demo server, I'm going to show you the things that you need to do to set up IntelliTrace. So you can kind of think of IntelliTrace as how we used to do it in the old days, where you would actually deploy debug symbols out onto a specific server, and you would leverage those debug symbols to capture diagnostic information during runtime. The problem with debug symbols was there's a lot of overhead and there's a lot of complexity to doing this. IntelliTrace has been very simplified. So what you're going to see here is I've created an IntelliTrace log folder. This is where I'm going to capture all my log information during my IntelliTrace process. Right now it's empty because I do not have anything in there. I also have an IntelliTrace folder. Now this folder has all the assemblies that you need to provide that IntelliTrace logging, and you only have to have it on that server during the period by which you're capturing that IntelliTrace information. Once it's finished, you can actually delete this folder. So you can see here has all my assembly information for IntelliTrace. Now the way I'm going to set it up is I'm going to take advantage of PowerShell. I'm going to take advantage of PowerShell scripting in Windows Server. You can see here I've got a couple PowerShell scripts that are executed by Windows command. Let me open up the first one, which is called Start IntelliTrace. And I'm just going to open that up with Notepad for the sake of not messing up my Visual Studio environment. And you can see here, this is just a simple PowerShell script that imports all the IntelliTrace modules that I had in that IntelliTrace folder. It fires off a command to IntelliTrace, letting IntelliTrace know to start collecting my information and where to put it. And then you also have this ASP.NET Trace XML file, has all the different settings for IntelliTrace. So you can actually go into that XML and change the settings if you wanted to. And then it tells which application pool to leverage to capture that information. And that's basically it. And I have the same thing here to actually stop it. So if I open up my PowerShell script to stop it, it does exactly the same thing, except it tells it to stop that collection of the IntelliTrace information. So what I'm going to do now is I'm going to run my command to start it. It opens up a command shell window, and I'm going to wait for that to execute. It's now executing the PowerShell script. The PowerShell script has executed. I'm going to go ahead and close that command shell. And at this point, I am now capturing IntelliTrace information for that application. So I'm going to go back into my application. I'm going to bring it up. And I'm going to fire off an exception. I'm going to fire off that same exception that we saw earlier, which is I'm going to go into my application. I'm going to log on, and I'm going to try to execute a report. And hopefully, this will come up sometime soon, since we're running in a virtual environment. And I can simulate the firing off of that error and how we can see that in IntelliTrace. So I'm going to log into my application. So I've logged in. At this point, I'm logged in, and I'm going to go to Reports. And let's see if I get an exception here as I'm trying to log into my application and go to Reports. Looks like I had to finish logging in first, so I'm going to log in. Okay, now I'm going to go to Reports. And it's bringing up my reports here, and I should see an exception sometime soon. There you go. So I fired off my exception, so I actually collected the information that I need. So I'm now going to stop my IntelliTrace. So I'm going to go ahead and stop it here. Fire off my command to stop that IntelliTrace log collection. And my PowerShell script executed. I've stopped. Now I can go back to my IntelliTrace folder, and I can see here I actually now have an actual log file. So now this is information that I, as a developer, can leverage. So I'm going to double click on this. This will open it up in Visual Studio, and it will bring me into a full IntelliTrace setting where I can start going through the diagnostics information of that error. So I can see here I've got a bunch of different exceptions that happened. I'm going to click on my null exception, and I can see here that I can start debugging as I want to. So I'm going to go ahead and click on the first one, and I'm going to say start debugging. So it's going to start the debugging session for me, and it's actually going to bring me up into that line of code where that exception happened. Oh, so it looks like I didn't have my code up here, but if I do bring up my code, and let me see here, I can go back in here, and maybe I'll pick another null exception here that will bring up, fire off my code here. There you go. And it brings me strictly into the line of code where that error happened. And notice, since this is a log file, I can compare it to playing a DVD in a DVD player. I can go backwards and forwards in time because all this information was already captured for me. So I can do real-time debugging in a historical fashion. So over here, you can see here, I've got my DVD controls. I can go back to the previous call or go forward to the call before that. And it allows me to look at all the different pieces of my code that correspond to the execution stack in that IntelliTrace log. So you can see here, I'm able to go to different parts of my code as I'm going through that execution stack. And that is the power of IntelliTrace. Now, obviously, if we were going to spend a lot of time on IntelliTrace, we could be here for another hour, but this is basically the main tool that you use to do that rich historical debugging in real time. So you can see here how we have the power of translatable artifacts between System Center and Team Foundation Server to allow us to capture all that rich diagnostic information and to take advantage of real-time production. So with that, I'm going to set it up or open it up for questions and answers, but you saw here a very brief overview of the benefits of integrating the tools that are used by folks on the operations side of the house on the Microsoft platform with the tools that are being used by developers on the Microsoft platform to create a very rich collaborative environment and the sharing of artifacts so you can bridge that gap between developers and operations and get to the full benefits of agile development. So if anybody has any questions, you're welcome to ask any questions at this point. If not, I would like to thank you for attending today's webcast. Looks like we don't have any questions, Liz, so with that, I'll turn it back to you.
Thank you, William, for this awesome presentation. If anybody has any more questions, please feel free to type them at this time. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. So the first question is, was this content helpful for your business? Second question, please rate the presentation content. And would you like us to schedule a follow-up? And lastly, how did you hear about the webcast? We will be forwarding the link to view a recording of this webcast once it becomes available. Again, thank you so much for joining, and we look forward to seeing you at our next webcast. You are now free to disconnect, and thank you.